Hello, students. We are continuing with the lecture. In the last lecture, we have seen that if you want to attempt to answer this question, that how does it work, that pragmatic measure, sorry, then you need to answer this question. That is, you need to check for these validities: concurrent validity, predictive validity, and construct validity. Concurrent validity, which refers to the extent to which the instruments can accurately identify the subject that differ with respect to given characteristics. So it should accurately identify the subject, and at the same time it must differ with the characteristics given. It should able to differentiate between the characteristics too. So researchers typically validate concurrent validity by using instrument in conjunction with a second instrument. So there should be addition of one more instrument, right? So two instruments in conjugation can be used here to validate the data. Then, for example, a measure of job satisfaction might be correlated with work performance. So here two measures are there. First, you have to measure it for job satisfaction, and the job satisfaction is correlated with the work performance. So work performance also you need to measure. So two measures are taken at the same time in concurrent validity. In construct validity, so how you validate the instrument? One we have seen with the concurrent validity. Second is construct validity. In this, it is useful mainly for measuring the traits or feelings such as generosity, grief, satisfaction. So it is more related to the feelings or emotions, right? So is related to the theoretical ideas behind the personality trait under the consideration. So whenever you have to study or analyze the data which is related to the emotions or generosity, with emotions or feelings, at that time you have to go for this type of validity, that is construct validity. And then the predictive validity, to predict some future occurrences. So the researcher commonly validates this, that by using the instrument you need to compare current situation and in future what can be the outcome. You can based on whatever current research you have done, whatever current problem you have tried to solve, on that basis you can give the predictive validity for that particular instrument. Now, testing the reliability of the research instrument. So first, it is the way how you can test is the stability. So whatever instrument you have developed or whatever instrument you are using, whether it is stable or not. So the best indicator is reliability, how much it is reliable. So if it is reliable, it will definitely be stable. So this refers to the extent to which some results you have obtained with the repeated use of the instrument. So as much as repeated use you're doing of the instrument, you're getting more and more data, more and more reliable data. So it gives that it is the which actually confirms the stability of that instrument. So there are two categories for test the stability: is retest. So test it again and again and again. So if your instrument is stable, it will give the stable data, and as per that you can say that it is reliable, right? And repeated observation, same thing. You have to repeat the observations many times, so that if repeatedly you are getting same stable data, then it means that your instrument is stable. Then for reliability, another measure is internal consistency. So this refers to the extent to which all parts of the instrument techniques are measuring the same concept. So whatever instrument you're using, it should give same consistency for whatever measures you are doing. 1, 2, 3, 4 measures you are taking, those which are coming under the same instrument, it should give the results with the same concept. Then test of the equivalence. This refers to the consistency of the result by different investigator or similar test at the same time. So you can give this instrument to test to different individuals or similar test at the same time you can do and find the reliability for the research instrument. Now the next part is data analysis. Data analysis, whenever you are doing whatever research, you first did the hypothesis, then you did the method, you performed the experiments, you collected the data, and now we have seen the different methods of data collection. We have seen what instruments you can use for the data collections and all the detailed parameters of those instruments also we have seen. Now how you can analyze the data, whatever data you have collected, now you need to analyze the data. So you first enrich the data, whatever data is there, whether your data is enriched or not. Then you need to examine the data. Then you need to triangulate the data. In a sense, you cannot use only one method for data analysis. You can use multiple methods. That is what is called as triangulate the data. So use multiple methods to analyze the data, and then you must able to explain the data. So there are many different types of analysis of data you will find. Few of them, maximum, I'm going to just explain. I'm just going to touch the surface part of this data analysis. The four main types of data analysis are descriptive, diagnostic, predictive, and prescriptive. So in descriptive, generally whatever data analysis is done is in a sense that what happened. So I have collected the data and I want to find it out that what happened in this particular problem. In diagnostic, why did it happen? So I'm going to find out the cause. By collecting the data, I'm going to find out the cause, that why it, whatever is happened, why it has happened. Then predictive, what is likely to happen in future. Then I will predict in this particular data analysis. Once I did all the data analysis, I can predict that this has happened and in future this may happen, right? And the next is prescriptive. What's the best course of action? Now, if this has happened, why it has happened, what can happen, and if I want to stop that, if it is not good, if I want to stop, then what course of action I will take to stop it. Or if I want to improve this, what course of action I will take to improve it. That is prescriptive type of data. Now, what is data analysis in research? That is the core definition of data analysis is actually to whatever data you have collected, you have to reduce the data to a story and interpret it into it to derive insights. So if you are having lots of data, it is not having any meaning until and unless you analyze it, you reduced it, you just categorize it, analyze it, summarize it, and then only you could able to tell something, some constructive about what research you did. So when you need to do it, when you did all the experiments, whatever your research topic is, you did all the survey, you have collected all the data, and at the end you need to form a story, that what is the problem, how it started, and how you try to find out the solution for it, which methods you have used, what data you have collected, and now after collection of the data, how you are going to analyze the data, or how you have analyzed the data, and what will be the conclusion after analysis. So the data analysis process helps to reduce the large chunk of data, because in data you are getting each and everything in detail, but then for conclusion you don't need, you need all the details, but you're going to do the summarization for that. So you're going to reduce that large chunk of data into a smaller fragment which makes sense, because the large fragment of data will not make any sense. For example, now those who are in science, they will understand it in better way. For DNA analysis or sequencing, every DNA is having ATGC. And when you do sequencing, when they did the sequencing, a large chunk of ATGC base pair is there. So by seeing just at ATGC base pair, nothing is getting understood, right? Only ATGC base pairs are there. But until and unless you don't find which part of gene is there, where gene is there, which part is not gene, which gene is responsible for what function, that all way, until and unless you don't find it, you don't analyze it, it won't make it any sense. Now there are three essential things which occurs when you are analyzing the data. First is data organization. Whatever data you received, you need to organize it in a particular manner. You can consider any characteristics or whatever parameter you consider for the organization. So you organize that data first, then categorize it. After organization, again make categories and divide that data into the categories. And once you divide it into categories, you can summarize it, because then it gets reduced, it get more focused, it get more narrowed, and now you can summarize. You can go to some conclusion and summarize it. So all this together actually contribute for the data reduction. And when you are analyzing the data, you will find different patterns in the data and even different themes into the data. And when you are categorizing it with the different patterns or with different themes, it's very easy for identification and linking the data with the some other facts or concepts. So mostly this third way or last way of data analysis is either top-down approach or bottom-up fashion. So you can either go from large data, make it narrow to your conclusion, or ulta, make some conclusion and then go to the large data, analyzing towards the large data. So there are a few scientists who gave the term, another term is given by another scientist, Macy, Rossum, Marshall and Rossum, who describe that data analysis as a messy, ambiguous, and time consuming. Of course, it's very hard work to analyze the data. It is going to take you a lot of time, and it is very confusing, very interrelated. But at the same time, it is creative, because at the end you're going to get something very creative and fascinating process, because at the end you're going to give such a excellent conclusion out of your research, which is novel, which is new. So through which the mass collection of data is brought in order, structure, and meaning. And by doing this, whatever collection of data you did, you're going to give put it into the order. You're going to give structure, a meaningful structure to that data. So that is what is actually called as data analysis. So after data analysis, you have to interpret the data, and after interpretation of the data, to interpret the data, you need to use different types of interpretation, and you can present the data. Now, why to analyze the data? Now, if a researcher want to tell that this was the problem and I have solved this problem, it needs to prove it with the data. And to prove it, it needs to analyze the data. Until and unless it won't analyze, it won't give the researcher any conclusion. So for that, it is actually very important to analyze the data, so that it could able to tell the story, or it could able to solve the research problem. It should prove that he or she has solved the problem. So many a times it starts with a question, and data is nothing but whatever. The problem is always your one question you want to solve, and data is always the answer for that particular question. So many a times there is no even question, and there is just exploration of the data without any problem. I'm not finding any problem, but I'm just exploring the data. Now, when this kind of thing is going on, it is called as data mining. So it is just because of interest, the researcher is trying to find out some interesting patterns within that data, and as per that, it is going to organize the data. Sorry. So that type of data analysis of data is called as data mining. So it is always expected from the researcher that while a researcher is analyzing the data, it should stay open, it should remain unbiased towards the unexpected pattern, because I want this particular result, so I'm expecting this particular pattern. So even if that pattern is not there, I'm a little bit biased and I'm trying to show that this pattern exists. So that is called as biasness. See, many a times when scientists do research, they are expecting some result. Now, if I'm doing one research that I want that my organism, my microorganism must produce indole acetic acid. But if I'm getting the result that it is not producing indole acetic acid, I should accept that it is not producing, because even a negative result is a result. So I should accept that. I should not be biased. I should not say, no, it is not producing indole acetic acid, but it is producing indole butyric acid. It's the type of that acid. So it has a chance to produce indole acetic acid. No, it is not producing indole acetic acid, means it is not producing indole acetic acid, even though I want that it should produce, but it is not producing. So that should get accepted, that whatever results you are getting, what patterns of results you are getting, what expressions of you are getting, what results you are getting, it should be stay open. And researcher should remain true to whatever results that researcher is getting. Now, sometimes the data analysis also tells the unforeseen yet excited story. Sometimes you're doing something else and you are getting something else. For example, the discovery of antibiotic is like that. Fleming was studying something else. He unknowingly kept some plates aside, and what he found on the plates, that one bacteria is producing something. Because of that, the another is not able to grow in the vicinity of that particular bacteria. And then he started finding out that what was that particular chemical, or what is getting produced by that particular organism, so the other organisms are not able to grow in the near vicinity of that particular organism. So sometimes such kind of exciting stories, in a sense, sometimes of exciting results you will get, which you are not expecting. You are not even doing that particular research, but you are going to get such results, and then you can start the initiation of that data analysis also. Now there are, as I said, different types of data are there in the research. We have seen 4 main types, but there are many other data analysis types are there, and even different types of data analysis are also there. So there is correlation analysis study. Now in this particular studies, the joint variation of 2 or more variable for determining the amount of correlation between 2 or more variables are studied. So there is causal analysis also, which is concerned with the study of how one and more variables affect the changes in another variable. So one and more variable, they are changing another variable. In first one, 2 or more variables, which are determining amount of correlation between the 2 or more variables. So these are the different correlation analysis. So here the relation between the variables, sometimes between the independent variable and variables, are studied. Now, this analysis can be termed as regression analysis also. Causal analysis is considered relatively more important in experimental research, whereas the most social and business researchers, our interest lies in understanding and controlling the relationship between variables than with determining causes per se. So, mostly this correlation analysis as relatively more important than the causal analysis, because in correlation you are going to study the relation between different variables. So in modern times, the availability of computer facilities are there. So there are many variables at a time. You can see multivariable studies you can analyze. So that is now also included into the study. So usually the following analysis are involved when we make reference of multivariate analysis, multiple regression analysis. So in this analysis is adopted when the researcher has one dependent variable which is presumed to be function of two or more independent variable. So accordingly, you have to use the multiple regression analysis. The objective of this analysis is to make prediction about the dependent variable based on its covariance with all concerned independent variable. So actually it is going to predict about the dependent variable based on the independent variable, that is multiple regression analysis. Now multiple discriminant analysis is again the analysis which is appropriate when the researcher has a single dependent variable which the researcher cannot measure, but it can be classified into two or more groups on the basis of attributes, right? Some attributes is considered and accordingly the researcher can classify it into two or more groups. The object of this analysis happens to be predict an entity's possibility of belonging to a particular group based on several predictor variables. So based on different predictable variables, the analysis can be done. So again, the multivariate analysis of the variance, where multi-ANOVA is also, it is also called. In this, this is actually the analysis of two-way ANOVA, where the ratio of among group variance to within group variance is worked out on a set of variance. So there is a ratio is find out within the group, and then the analysis is done between the different sets of the variables. Then canonical analysis, in which the analysis can be used in case of both measurable and non-measurable variables. As we have seen that there are some measures you can measure, some are you cannot measure. So for this purpose, in this particular analysis, you can take both the measures for the purpose of simultaneously you can predict set of dependent variable from their joint covariance with the set of independent variables. So dependent variable and independent variable, both variables can be jointly predicted. That is what is there in canonical analysis. Now the last, that is inferential analysis, which is concerned sorry, which is concerned with the significance for testing hypothesis in order to determine now to test the hypothesis, various tests can be done, and that will determine with the validity of the data, and that indicates some conclusion or conclusions. So it will show some inferential analysis, some inference will be there, some conclusion will be there. So that analysis can be done, and it is mainly on the basis of inferential analysis, that the task of interpretation. So in this, mostly the interpretation is preferred. Now to the main data type, and then we will see how it gets analyzed. So the first one is qualitative data. When the data presented, which is in the words or description, which is called as qualitative data, it is always subjective and harder to analyze, but especially you can use this data for the comparison. So example is focus group, personal qualitative interviews, qualitative observations, or using open-ended questions in the survey. That is the best examples of qualitative data. Means qualitative data you can collect with this. Then quantitative data. This is the data which is always expressed in the number of numerical figures, which are called as quantitative data, which you can categorize the type of data with the groups, categories, measures, calculated, or ranking. We have seen all the examples of this. So the questions such as age, rank, cost, length, weights, scores, this all comes under this type of data. And you can present such data in graphical format. charts, or you can apply different statistical methods to this particular data. So always qualitative data is the best data which can give you more correct and significant results. So outcome measurement system, that is questionnaires or surveys, also you can use in to collect this type of data. Then categorical data. Now this data presented in groups. So for example, a person is responding to the survey by telling his living style or marital status, smoking habit, drinking habit, whatever he does in his life, that is actually under the categorical data. And the best, this data can be analyzed in the best way by using chi-square test. Now, data analysis. Data analysis in qualitative research, quantitative we have seen. So data analysis and qualitative data research work, a little difference is there where numerical data is there, and in qualitative analysis, the data is expressed into word, description, images, objects, or some symbols. So there are different patterns you can find in qualitative data. So what, for example, while studying data collection from African countries to understand the most pressing issue people face, researcher might find food and hunger. So in Africa, what researcher found that he was collecting the data, but what the most important problem, what people are facing there, what researcher found that food and hunger are the most commonly used word, and will highlight them for the further analysis. It means there is some problem with food and hunger in that particular area. The keyword contest is another widely used word-based technique. So in this method, the researcher tries to understand the concept by analyzing the contest in which the participants use particular keyword. So I have taken some respondents or participants, and every time they are using some words like food and hunger. So that can be a keyword also, food and hunger. So another example we can see, the researchers conducting research and data analysis for studying the concept of diabetes. Among the respondents, most analyze the context of when and how the respondent has used or referred the word diabetics. So suppose whatever data you are collecting, many of them are telling about themselves and they are saying that they are diabetic. So the diabetes and whatever research you are conducting, there is some relation. So you can keep it as a keyword, or you can just consider it as a keyword contest. The scrutiny-based technique is one of the highly recommended text analysis method. Then, for example, to find out the importance of resident doctors in a company. So, collect the data, whatever data is collected, divide it into the people who think it is necessary to hire a resident doctor and those who think it is not necessary, and then compare the contrast, that which one means who is saying what, and what percentage of people are saying that resident doctor is needed and what percentage is saying unnecessary or it is not needed. And then you can analyze with the polls having single answer question. So yes, no, want it or don't want it. Then metaphors can be used to reduce the data pile and find pattern in it so that it becomes easier to connect the data with the theory. Then there are different methods for data analysis in qualitative research. There are several methods. We are going to see which are commonly used method. Content analysis. It is widely accepted and most frequently employed technique for the data analysis in the research methodology. So it can be used to analyze the documented information from the text, images, and sometimes physical items. So you can just analyze some information from text, images, and physical items that when you are analyzing, it is called as content analysis. Then another is narrative analysis. Now this method is used to analyze content gathered from various sources, especially personal interviews, observation, and surveys. So those are narrated. So many a time people, when you are taking interviews or doing observation or asking question regarding observation and surveys, people are narrating the experience or whatever their stories or their opinion. So that is that when you are analyzing, it is called as narrative analysis. Discourse analysis, so in that it is actually similar to the narrative analysis. Discourse analysis is used to analyze the interaction with the people. So a researcher is interacting with the people, or a particular person is interacting with the people, and you are studying that person. So like Sadhguru is there, and how he is interacting, if somebody is doing research on it, how its social contact is there, how it is giving discourses, how the discourses get analyzed by the people, what people think about it, what is the lifestyle of Sadhguru and all that. If you are studying, it is called as discourse analysis. In addition to that, discourse analysis are focused on the lifestyles and day-to-day environment while uh, deriving any conclusion. Now, grounded theory. When you want to explain why a particular phenomena happened, then using grounded theory for analyzing quality data is the best part. Then grounded theory is applied to study the data about the host of similar cases occurring in the different setting. So case is similar, but it is happening at different areas or at in different settings it is happening. So when researcher use this kind of method, it might alter the explanations or produce new ones. It may get some situation is same, even theory is same, but getting results differently. So they may arrive at some conclusion, or it may be same conclusion, or it may be even different conclusion too. We need to stop it here. So we will see the next part in the next lecture. Till that, bye.